Hello ladies and gentlemen, welcome to my video. This is today's questions. Do we need to combine all three of them, become one big integrand and solve it from there? I think this is a bad idea. A better way is we solve it one by one and total up. Let's label the integral as J1, J2 and J3. Solving J1 without a computer is possible. In fact, I can show you within a minute or two. But solving J2 and J3 directly without a computer is almost impossible. The strategy is we solve J1 and then we differentiate the result of J1 to get J2. Yes, you heard it right, it's differentiate, not integral. After we get the result of J2, we differentiate again to get the result of J3 and then we total up to get the final answer of these questions. Let's define function J1 beta, which is equals to integral 0 to infinity natural log x and then divide by x squared plus beta squared and then dx. When beta equals to 1 over 2, the result will be equal to the part 1 of the questions. For the denominator, we factor beta square out, which means we have beta square and then multiply x square divided by beta square plus 1. Next is to do substitution. Define u equals to x divided by beta. Therefore, x equals to beta u, dx equals to beta du. When x is infinity, u is infinity. When x equals to 0, u equals to 0 as well. And then J1 beta become integral 0 to infinity natural log beta u divided by beta square and then multiply u square plus 1 and then beta du. From here, we can bring 1 over beta out from the integral as a constant and rewrite the numerator become natural log beta plus natural log u. Take note that u is dummy variable of calculus and we are dealing with the definite integral that the final answer is a number. Therefore, we can change the u to another variable name such as x. Label this as equation 1. Next, inverting variable strategy, change the x become x power negative 1. Therefore, dx become negative x power negative 2 dx. Infinity becomes 0 and 0 become infinity. J1 beta become 1 over beta integral infinity to 0 natural log beta plus natural log x power negative 1 and then divide by x power negative 2 plus 1 and then multiply negative x power negative 2 dx. We include the new terms which is multiply x power 2 divided by x power 2 which is equals to 1 over beta integral 0 to infinity. We swapped the integration bound because of cancelling the negative here. Numerator become natural log beta minus natural log x, while denominator become 1 plus x power 2. Label this as equation 2. Here we can apply equation 1 plus equation 2. By doing so, the natural log x are cancelled. The left hand side is 2j1 beta, while the right hand side is 2 multiply natural log beta divided by beta integral 0 to infinity 1 divided by x squared plus 1 dx, which gives us j1 beta equals to natural log beta divided by beta multiply inverse tangent x. Put in x equals to infinity and x equal to 0. We can conclude that j1 beta is equals to pi multiply natural log beta divided by 2 beta. When beta is equals to 1 over 2, J1 is equals to the first part of the questions, which is equal to negative pi multiply natural log 2, which is approximately equals to negative 2.1776. Keep this result for calculation of the final answer later. For J2, we don't have to do the derivation all over again, but we just have to extend from the J1. How do we extend? We extend by applying differentiate over d beta to the both sides of the equations. For the left hand side, we have to use partial fraction symbol because there are two variables x and beta. Left hand side become integral 0 to infinity negative 2 beta natural log x divided by x squared plus beta squared and then the whole thing power 2. Don't forget the dx. While the right hand side is constant pi divided by 2, and then denominator is beta power 2, while numerator is 1 over beta multiplied beta minus natural log beta. Bring the negative 2 beta in the left hand side to the right hand side and then further simplify the right hand side. We obtain the J2 beta, which is equal to pi divided by 4 beta cube and then multiply natural log beta minus 1. When beta equals to 1 over 3, J2 is the answer for the second part of the question Q, which is equals to 27 pi divided by 4 and then multiply natural log 1 over 3 minus 1. Approximately equals to negative 44.5026. We need this result when calculate the final answer later. For the third and last part of the question, we don't need to do the derivation all over again, but we just have to extend from J2. How do we extend? We can extend it by applying differentiate over d beta to the both sides of the equations. After differentiate, left hand side become integral 0 to infinity, negative 4 beta natural log x divided by x power 2 plus beta power 2 and then whole thing power 3 dx. Right hand side equals to constant pi divided by 4 and then denominator is beta power 6 while numerator is 1 over beta multiply beta power 3 minus 3 beta power 2 and then multiply natural log beta minus 1. Let's bring the negative 4 beta in the left hand side to the right hand side and then further simplify the right hand side. We obtain J3 beta, which is equal to negative pi divided by 16 beta power 5 and then multiply by 4 minus 3 natural log beta. When beta is equals to 1 over 4, J3 is equals to the last part of the question Q, which is equal to negative 64 pi and then multiply 4 plus 3 natural log 4, which is approximately equals to negative 1640.4407. Now we have J3. Combined with the J1 and J2 we found just now, we have all three values. Sum them out will give us a final answer, which is equal to negative 1687.1029. Thank you for watching this video until the end. Please continue support my channel, subscribe, give a like and share my video in your social media. See you tomorrow for more video. Bye bye.